Hey guys, welcome back to the channel. I have another BMW test. This is a 2013 N26 3 Series. Customer comes with like no turbo actuation, lead mode, and a lot of codes. He has a lot of under voltage fault codes. I said, I need to replace the battery in the ground strap, which was horrible. And during retests, I have seen a lot of these vehicles with faults that recommends at the end replace the turbo. Not sure if it is going to be the end of this one, but I told the customer I want to do a test properly, not just what the test plan recommend you to do, because it's not fair. I mean, definitely we all know that dealers are not made to protect the customers; they're there to make money, and we are not here to do that. We are here to protect our customers to make sure that what we recommend is the actual right recommendation. So as you see, I have kind of like created because I did purchase this from BMW. This is a harness specifically for N63s and all the new electrical actuator turbos. So you will connect one side to the turbo and another one to the actual harness on the car. It doesn't come with any of these connections in here. So what I did is I cut the wire, solder it, and I put my own 4 millimeter banana adapters on each of the firewires, and then I can plug my oscilloscope, which this is a test lead, but I don't know what was BMW going to do with that because it's just a connector to make it longer, as far as I could understand of what I saw. But so what I have seen with these actuators is when they get warm, the signal, position signal, it gets so erratic that it throws the vehicle into limp mode and then control falls for short to ground, short to power, or just a turbo fault code. And so since it's not in a specific fault, or problem, I want to make sure that this is not what I'm experiencing on this car, and then give the right recommendation to the customer. So again, the turbo actuator, for those that don't know what it is that one right there. This just links to the turbo at the bottom. Let's see, I got a light in here. So you can see the linkage right there. That's just the turbo wastegate. Every time you turn the vehicle off or reset the faults, the car will try to read the limit positions of that turbo wastegate. Cold, I have no faults right now on the turbo. So I'm actually, what I'm doing is letting the engine warm up. As you can see, I have engine RPM and coolant temperature and engine oil temperature, which is very important on BMWs. As far as connections, you can see here what I have right now. Blue channel is the 5-volt reference. On pin 2 for the wastegate. Red channel is position sensor signal on pin 4. Green channel is pin 1, one of the motors. This is a pulse width due to the speed that I have. You can see it like a solid bar, but it's a pulse width modulated. Yellow channel is pin 5, which is again on the motor. If I accelerate the car, can you please do a rep? I need it here. Yeah, I need it here. Stay here. Like so. Do a rep. 1 second. Sorry, guys. Okay, so we're going to do a rev right now. You will see the changes on the red, which is the signal. All grounds, as I'm saying in here, are going to the sensor ground, so everything is, should be clean. Okay, do a rev. All right, we didn't see that. No movement on the turbo, so this might have already set a fault. Do it again. It is trying to move just a little tiny bit, but it is not moving. Let me stop the capture 1 second, guys. So this is what we see here. So turn the car off. Ignition back on. All right, let me go over to the fault code. Let me close this and see if we have a fault. Let me read the DME. You can gather fault codes. You don't have to start the vehicle test. Sometimes you do, but just running control unit tests. Again, the turbo wastegate will be controlled by the DME. So we can just do that and see if we have indeed a fault. Um, hmm, we look like we don't. So let me restart the test. I don't want to do that. I want to go here. Let me do the start vehicle test. Let me pause the video so it's not too long. All right, guys, I did I start again? Yes. Well, we got actually transfer case. Yeah, because this car has also transfer case problem. Nothing to do with the turbo. Compressor clutch, braking, no message status, AHM transmitter. All this is with a transfer case and nothing to do with the turbo. Still, I didn't see any movement. So let me wait for my helper because he's doing something else to come back and we're gonna reset the ignition because I can definitely see now the wastegate and I want you to see that linkage. You see how it's extended right now? I'm talking about, let me put the light right here. Yeah. So what I want you to see is the distance between here and there. When the car starts, this retracts. And when you accelerate, if normal condition, that should move to release the pressure. This turbo, especially in the N26, it has a bypass valve. So the outer valve that we see here, sorry, right there with those outer screws. Let me again put the light here. Trying to do my best to explain the system. Right there is a bypass valve. So that's kind of like if it's too much pressure, it will release the pressure. So far we have no turbo faults. So let me wait for him and then we proceed with the test. But yeah, so what I'm trying to do again is to warm up the temperature, warm up the turbo and see if the actuators start to get glitches on the signal or we lose power, we lose the ground, something that otherwise is the actuator or a wiring or is a bit turbo, right? So that's what we're doing in here. All right, he's back. Let me go back to the DME. I want to see the changes in temperature as we're doing this test. Those are just the ones that I don't think we have any wastegate. Let me see. Charging pressure. Well, we should probably want to see that, right? Intake pressure, throttle valve opening, just to see what the volume on air. We can see the mass airflow sensor. Let me see if there's any PID. I doubt there will be any PID in here for the wastegate. Just going really quick. Trying to make this video not too long. But yeah, there is not how did I set undo all? No, I didn't do that. All right, let me undo all and then let me reset speed, coolant temperature, battery voltage, air volume, throttle angle. You can see the set point. So this is a Valtronic engine, so that should not change too much. And that should do it. And now let's get the Pico here in the screen. Now we can click in here. Why is it doing that? Come on. Oh, because I have it big. All right, start the car again. You see the signal, it is changing because right now we're in 1.2. Let's see that wastegate actuator. If by any chance the turbo changes, I don't like that what I'm seeing in here. I didn't like what I'm seeing in there, so let me stop this 1 second. Turn the car off. You see, just in a second in there, it was changing, and I could hear it. What a coincidence. Well, probably just because we turn it off, but before we turn it off, before it was extended. Right now it's retracted. You see the length on that? And we can see how that changed for the second. The car by itself, because there is no idle, we didn't apply any idle change. We could see that the yellow went high because the yellow right now is in 0.156. If you want to see the value, it's just 155 millivolts. The green is in battery voltage, again, pulsated battery voltage. But it went from there to 5 volts, almost 5 volts a signal with no acceleration or anything. Before that is things that I don't like is this, because we're still just getting a ground in here, but the green, which should be power, right? Pulsated power is getting all this right now. So let me do a zoom in here. You see, this is not looking good. So that doesn't look good. Let me take it over to here. Gotta collect the zoom. Let me take all those lines out. We no longer need it. See, this is a lot more of battery voltage being applied. And then if we go forward, just before, let's go back to, oops, change the trigger position, doesn't matter. Like right here, this is what it looking like normal, let's say, right? Let's see what the pulse width is doing in here. So it is pulsing for a very short period of times. Let me see how long. Am I gonna have to increase my sample rate because I can see a little bit of a aliases in here. Yeah, that's like a 28 microseconds every 300 milliseconds, 320 milliseconds. So it's pulsing very rapidly. So a pulse every 320 milliseconds of 38 microseconds. Um, is that good or not? Not sure yet. I honestly don't like the signal at the beginning because the car was running. We can see, all this deteriorate signal. How is the car running? And then it went from like all these glitches, right? Without us changing anything. The position of the turbo didn't change, and we can see that in here. It stayed in 1.2, but we got all these weird actuations because you see when the yellow channel is being active, it's being active for long. You see it right now, if I measure right here, so we got in here, we got 14 volts on the yellow channel and then like release it for a second. So if we see this here, you see it's not like a pulse width modulated signal like as we see here on the yellow, I'm sorry, on the green. It's more of a solid, either power or ground, but not here. I got actually another capture. Let me open that one up. It's from an N63. So I'm gonna have to cover because it has the customer information. So give me 1 second. All right, guys. Again, this is a test on another vehicle. So this is just a save file from an N63 engine. It uses the same actuator. So I'm pretty much the same way connected. Fiber reference on the blue channel. The red channel is the signal, as we can see. And here we do an acceleration. And then the power and ground, which is going to be reversed and depends on what you want to do with the actual actuator or the computer wants to do with the actuator. But let me take a look at this pulse width modulated signal just to have a comparison to the other one, right? Like that we know if we have, because this is actually after I replace it. So I want to know how long it stays on. So this is like around 87 microseconds. So it is a fast pulse width, and it's around 1 millisecond. So let me go back to the capture of the customer in here. Don't sense and no. Oh no, it has encountered a problem. Might have to lock. No, don't go away. So the yellow one is the one we are in problems. So let me just go back to that capture because this one is going from ground. If I am correct, from ground, right? So yeah, from ground to power. And then the yellow, oh, sorry, the green is a solid ground. All right, so but in his car, I have to like see, yeah, this one. In his car, let me take the zoom off. Yeah, this was not in ground in here. So let's go back to a place where we are actually, oh, I keep hitting the trigger. Like where the yellow is at ground, I want to see that to compare. So let's compare after these events. I need to put a ground, a zoom in here. Okay, so it is doing the same, right? At least after that event. So yes, from ground to power, from ground to power. Let's do a little more zoom in here. And now we can measure, well, that's actually too much because I need to see at least two events, right? Okay, that should be okay. So this event was 22 microseconds, so very short compared to the other one, right? And then the distance in between these two is 500 microseconds. In our known good, we got 1 millisecond. Hmm, that is a big difference. Just trying to do an analysis. And remember, guys, this is not recorded, this is live. So we're having half a time of the activation. But still, I cannot consider that any bad because we're not fully warm. The other one, the other capture, let me see what I put any notes in here. Engine running. I'm not sure if it is cold or not. I have some more captures in here. So let me see if I have anything that I want to see. 1 second, guys. This is engine start after repairs. Engine warm up at 96 degrees. Engine running, accelerating, pausing from. Let me just show you what the problem that I want to find or try to see on these vehicles is this. Again, this from the other car and the N65, N63 was working perfectly. But, and this is now actually good. I like this because I can see that we were actually, the voltage is actually 4.3, which is what we got. And then when I accelerate, see, this is acceleration, it will come down to like 3.6 volts. So that's the, remember the signal, and we can see the change on polarity, even though, again, was working kind of okay. So I'm going to do a zoom in here, and I want to show you what was the problem on that car. But yeah, we can see the pulsing in both signals, not a full ground yet, but might be because of temperature. But if we see this part right here where the sensor signal is, we see all these glitches. Let me turn the green channel off in here 1 second. I didn't want to do that, so I'm going to go view, and then you see all these glitches that should not be there. This is like a temperature position sensor, like a TPS or something like that. Should be a nice steady signal, not disrupt, because otherwise it's going full open for close, full open for close. Computer doesn't know what it is, right? And that's what I'm trying to pick up with those with this other one. So let me keep doing the tests. Let's go on the temperatures of the car. So start the car again. We can see the turbo's in control, you see? So the turbo's in control, the car is in control. So I cannot call anything yet as bad. I didn't erase any fault because there were no faults. All I did was a vehicle test. I'm not familiar to see what we're seeing here, with all this stuff, but it might be that just a computer strategy. If the computer is in complete control, if it would be a problem with the drivers, the computer will have to set. Let me remove the um, trigger. We don't need any triggers right now on the signals. Like that, we got just a free roll recording. But see, right now we're in 1.1. I can hear a little bit of a change on the idle of the car. Sorry for the camera movement, but nothing is abnormal. So let me warm it up and I'll be right back. See guys, I just changed the idle by itself, but normally, this is all normal. So it went from the 1.1 and went over to what we see on the N63. Remember 4.1, 4.5 volts or so. So this is completely normal. And all is, the computer is now in control. I can definitely hear. So when the car starts, BMW raises the idle So that's just a strategy the computer is using to keep the idle as whatever it wants. And when it's happy about, like, 2 minutes or so, it will drop the idle completely based on temperature and other factors. But so far, all good with the actuator, right? See, guys, one thing that I don't like is, like, see, right now I turned the car off and I went to move the wastegate and it was completely pulled back. Right now the idle is normal. Do an acceleration. Let it go. And we can see that on the image in here. So it is in complete control. Right now we're like in 74 degrees, so it's still warming up. What I want you to see is these accelerations. So we're gonna try to do another one. Do it again. Let's not do that high. You can just go like room and let it go. Let me just save this one. 1 second. 1 second. Let me save this capture. All right, click the stop button. So I'm gonna have to edit the video. All right, guys. And we can see the acceleration in here. See what is going up and down, and but then boom, and went up. So it's now that completely pulled back. You see what I mean? So now when the turbo is like this, it stays in there. Do an acceleration. Higher. Looks like the pin on the turbo is also broken, for the wastegate. And we can see right now the signal on 4.5. In the N63, I was able still to accelerate. Do it again. You see no change on the position sensor because let's see if we have any command by the computer. I'm gonna wait for the screen to start again. Hang again. You see, and we got command. We got command from the computer. Turn the car off. So when we turn the car off, see how like you see how the wastegate is staying stuck in the back? And I think this is based in now in temperature. The hotter it gets and the worse it gets. Because let me try to push, and this is what I was trying to do here. Yes, but this is the pinning, the holes that is broken in there. See, the wastegate actuator should be all the way to the back. Put the ignition back on. You see, that's the normal position. You see, that is the normal position. Turn the car off. Turn it back on. You see, that's what the wastegate actuator should do every single time. Back and forth, read the positions. And now, with that done, same temperatures, see the position is right now, start the car. See, the position is staying in there, it's not changing. Same idle, low idle, everything is good. And we can see this now in ground and this one pulsating with no movement. All right, do an acceleration. You see, it's in complete control. Do it again. That's enough. Uh-huh. And we can see that it's in complete control. Do it again. So we're going to see when that change happened. If it's the computer commanding that turbo wastegate to stay there, why it's happening? Because as long as that red channel is high, you see where we are right now, the yellow is in high. You see it went to low, so the computer did change that. Hmm. Do an acceleration. We can see what it's trying. Do it again. So the computer is trying to move it, but it's not moving it yet. So turn the car off. But this got stuck into a position it shouldn't be. Turn the ignition back on. Okay, so the computer was able to move it. Ignition off. Ignition back on. See, it's doing the sweep. This is the computer checking, okay, what is my end position? What is my start position? We are good or not? Start the car. So when we have 1.1 volts on the signal, the yellow signal is ground. Oh no, it's battery, sorry. And when the computer wants that to go lower, so when this one goes to ground, the signal goes up to 4.5 volts. So up to there, I can consider that normal. This is still a normal operation because we can see the command of the computer. If this would be like a, on the acceleration, it gets a stuck. I say, okay, the actuator is getting stuck. But if the computer is the one is commanded on, like on in here or off, like off of the yellow, going to ground, and then the signal is going up based on what the computer wants to do. We will see that in a second. Right there. See, all this time before this change happened, we can see the movement of the turbo wastegate, and we can see it also on the wastegate, right? But we don't need to come here because we can see it on the oscilloscope. Right now, if I perform acceleration, do an acceleration, see, the thing that I don't like is you see how this is commanded it on. So let me stop this running capture 1 second. Hopefully we got enough of both worlds, and no, we don't. One thing that I want to do is see right here. Let me get all these lines out. I want to see what the computer is doing. So we are not grounded. When this one is being power, yellow is in high as well. And that's probably why it's not moving. Because the only time we can move the turbo, and I'm going to be, so what I want you guys to focus is in this. Okay, the computer is commanded it on to go high, but not to retract. Why am I saying that? Okay, because we can see the yellow go high, but they also the green. Because you see how in here we're going from ground to power, and now in here we're going from power to ground, pulsating the opposite way. So that's how it's happening. So turn the car off. All right, so when we see this, if I remove all this, turn the ignition back on. Now we did a sweep on the position sensor. If we go back to visit that, that will actually give us all the answers right here, right? So we are high. Like you see, we're went high. So let me just do a check in here. A little hard to see with that distance in there. Can I go? We got 1 second per division. Let's just start the car back on. Again, we got the position of 1.1. Not changing, not changing. I want to see this in completely power. Not yet. Computer is doing its thing. And this one is going to stay low until it's reaching up to 5 volts or 4.5, right? Do an acceleration. Let it go. Lower. Okay, I want to analyze this one right now. Turn the car off. Don't want to get like super extra hot, but okay, things that I see a little different. Okay, we're still in the same voltage on the sensor. See, I went back to 1.3, but we went now from ground on the yellow, right? Let's focus on the yellow. I'm going to put another signal or another line in here. So we're still on ground. We did an acceleration. The turbo did his thing. So we went from not ground to whatever the green is doing. And then a couple of activations of the yellow channel, and then boom, it went up. Now it's high. But when it's high, you see, we got this one high, but if we go and see the green, I bet you the green is coming from ground to positive and not the other way as we saw before. And this is exactly where I wanted to catch it. No. Hmm. And it's actually starting high. Let's do one smaller part. So let's do here. Yeah, that's so. Even at this position, we got 14. No, we got how much? Yeah, 14 balls on the yellow channel. And this is pulsating from positive. Was it has a longer positive pulse than the negative. All right, so we're going to see the change now. Let's start the card again. Start at the sweep. This time it stood in a high. Turn the card off. See, this went up to 5 volts. 3.6 volts. Yeah, we can see the position on the linkage as well. Uh, Ignition on. So now went down to 1.2, and this is high. Turn the ignition off. We can see it on these two channels when I turn the ignition off. Ignition back on. This one is staying high, and this one is staying high too. Start the car. Say this one is low. What is the green channel doing in there? Trying to dissect this signal. It's low. So yellow low, green low. When that happens, the signal is low. So now we have yellow high, and I bet you green is high. You see, green is high, and the signal is low. Right, when both signals are following the same position, let's say, either yellow is high, green will start from high, that signal position will not move. So we're low and low. You see what I mean? Do an acceleration, but this time right now the turbo is staying low too. See now the turbo is staying in 1.2 and the idle is low. Okay, we went high. See, we went high. As soon as that happens, let's see what happens. I bet you now yellow and green are not doing what they were doing before. Because we got green low, I mean, sorry, yellow low, we should have green low as well. It is low. Let me save these guys. I'll be right back. All right, guys, I think we definitely have a bad actuator because, all right, so we're going to try to duplicate this again. I think I understand the signals now. And this is how it is because if you try to look for any of this information on ISTA, good luck with that. So we are around 87 degrees Celsius on the coolant temperature and the oil are the same, which is another test that I want to do because this car was having some coolant temperature faults in the map thermostat. All right, so I'm going to start a car. Let me put some cursor again. 1 second. So let me put a cursor on the signal. We're going to put a cursor on the yellow and then a cursor on on this one. I don't see any problems on the signal wires. I'm just going to turn this channel off. Like that we get more sample rate per channel and more accuracy. All right, so we got everything as we have here. All right, so let's start a cart. I put a little more time base, so two seconds per division. So we can see now that both signals are low and the turbo is in low. Do an acceleration, not that high. Let it go. Uh-huh. So right now, when this happens, and we now know this, so let me save this 1 second. The reason I want to say that is because I know that here will be low and low, and this will be high and high. And we can see that now. See the signal? The green is starting from low to high when yellow is low. If I go over to the other side, when now is yellow is high, I guarantee you the green is now high, and it is. So green is starting from high to low, high to low, high to low. So a lot more positive signal, right? But then when both signals are in the same edge, the position of the turbo wastegate to be always in 1.2 volts. So let me run this. But right now, we got the position of the turbo is not there. So we are now in 4 point something. Try to do an acceleration, same not that high. See, we got no turbo actuation. Turn the vehicle off. Give me 1 second, guys. All right, guys, sorry I got interrupted and now I don't remember what it was. So let me just think about it. So we got this signal on 4 or 3.6 volts, which shouldn't be there. So this is a position the computer doesn't understand. But if we go over to here, let's see if we have a fault. Because we can do a DME test. And this is all original BMW. This is no Chinese, nothing. This is original. For those that wants to know, so let's display it. We have absolutely nothing on the turbo wastegate yet. Not enough to set up a fault yet. I will probably have to drive the car for this to set up a fault. So let's go back to troubleshooting. Let's go back to the DME and let's look at the temperatures. I think I'm going to just keep it with those in there. So we're around 87 degrees. Start the carb up. Oh, sorry, put the ignition on. See, when he puts the ignition on, the signal goes down to what we're looking for to have, 1.2 volts. And the other thing that should happen when the car gets warm, it's okay to go up to 5 volts or 4.5 because looking at the N63, but again, that's an N63. I don't have a knowing good on an N26 or an N20. I might be able to get one other car from here and do all these connections, especially since it's very quick here. And then try to save a known good. See if this is actually normal or this is actually an actuator that is getting stuck. For what I'm seeing here, this sounds for me as an actuator that is getting stuck because I start a car. If I just start a car right now, do an acceleration, I can see it on acceleration. Do another one, same height, that's fine. We can see the turbo movement. You see, we can see the turbo movement. We can see it coming back to 1.2 volts all the time. As long as we do that, and these two signals are, which is the motor voltage, I just put probably grease on my face, are okay. There is all good. I don't understand what is exactly the computer trying to do with there, but as long as this is not changing, I will consider that okay. Doing a small acceleration. Yeah, we can see that movement and moving good because when that moves, let's say, it's reaching 4.5 volts. Do it again. You see 4.5 volts. So it goes from 1.2 to 4.5. Doesn't matter what is changing in here, right? Because the idle is now, the engine is warm, idle is good. We got no faults. Do it again. Go a little higher. Okay, you see? Now we got a fault. It went back and it got stuck. But this is stuck in 4.5 volts. Do an acceleration. It's not moving. Turn the car off. See, it went down to 3.6. It couldn't move it all the way to where it's supposed to. Ignition back on. See, this is what it's supposed to be doing. That, not that little glitch. Turn the car on. See, if this will be the normal position, same temperatures and everything, nothing is changing. Why is doing that, right? So, as long as we're doing a small acceleration, do a short acceleration. All is normal. Another one the same. All that is normal. As long as we do short accelerations, that is all working good, and now we'll consider this to be normal. Do a longer. I was still happy. One more time. And there we kind of see it kind of did it. You see it went like the signal didn't read properly. Do it again. 1 second. All right, I'm going to try to do the limit position test plan. Even though there is no faults in here, I'm going to calculate the test plan. Let me see if this is the correct one. I try to make this small, see in the background what is doing the turbo. When we do this, since there is no fault memory entries regarding a terminal change must be carried out. To perform the terminal change, click next. This will turn the ignition off by itself. And we can see that it's doing that. We can also see it here on ISTA by terminal 15 being 0 and then KL30 being battery voltage. All right, so we can see what the computer is doing. Complete status of wastegate system. The system test was completed without errors, but the wear of the exhaust supercharger is already approaching the fault threshold. So, see, this is what we are getting in here. Press next to continue. Let's see what else. This is going to say replace the following component. So we do have a turbocharger problem. If only the electrical wastegate valve controller is replaced, it is highly probable that the complaint can only be temporarily rectified. Even adjusting the wastegate linkage only constitutes a short-term remedial measure in this case. And that is what I don't really agree with all these test plans and everything they said. I'm going to perform the test plan again. So let's end the test plan again. Let's see what the position is right now on, yeah, we got 1.2 volts on the wastegate. So let's run the test plan again with that position. And fully warm engine too, right? See if we see when the computer does that, if we see any drops on the signal. It's going to do the same thing. It's going to read the DME, and it does. It's going to do a terminal change as we saw before, and it's going to do his complete sweep from back and forth. All right. let's change like next. And I might reduce the time to make more screens, or maybe the sample rate, because we're only getting one waveform. That might not be enough for what I need, right? All right, so let's see how many screens are we saving. 2. Okay, so now we got 2. So let me start that test now. We can see, you see, I don't like that signal in there. So let me stop the capture because now we're just going to get the results from the test plan. Status of the Wastegate valve system. The system test was completed without errors, but the wear of the exhaust supercharger is already approaching the fault threshold. And this is where we're going to get the same, replay the Turbo Wastegate. But if we go over to that capture, see things I don't like. Let me put a small filter onto the red channel. That should be good enough. Not sure why I'm not getting, megahertz if I want to. Let's see if I can put 3 megahertz. No, it's not letting me. Maybe because I'm messed up. I can either remove it or I can put a 50 kilohertz. So yeah, looking at the signal, now I don't see any drops on the signal. Let me get the cursors out. By doing analysis, just right now, I see the hump. And that hump is the one I don't like because this should be really linear. It's a linear test. So it's going from 1.2 to 4.5. And we see here, we got the 1.2, right? And to 4.5, right? That's what we're looking for to get, 4.5 or so. I don't like the drop in here. So it's reaching even further. And then it's coming back to 1.2, which 1.2, are we in 1.2? Let me save this capture, guys. I'll be right back. Yeah, I'm a data analytic person, so I just saved that recording, that file too. So let's see on live, where are we in 1.2? So the only way that that turbo can reach more than 1.2 is if we go back this way, and I can prove that. So I'm going to manually pull that wastegate further this way. Not that easy to do. I guess not because the ignition is on. I mean, we can see with the ignition on. Let me turn the ignition off. So actually, no, this way is higher. So closer to the actual actuator itself, I get higher voltage. Lower voltage is only when it goes further, and that's when it's doing the test. So that is actually good or normal. I can only move that with the vehicle off. Let's see, because right now I think the ignition went off. I mean, the car went to sleep. So right now it should be reading 0 because there is nothing in there. I hope I didn't ruin the camera. Now it's facing backwards, but otherwise I would have edited. Yeah, with ignition on, it's on 1.2. So only when it's doing its test, it will move the turbo further, and it will move the turbo further this way. But it's not changing in 4.5. Because if we reopen that capture, and that's what I like to save all the data. Let me see, where is it? Right here. Test plan. Just getting the camera down because I got all the customer information in there that I don't want to share. So we know that when the turbo is closer to the actuator is when we're reaching the 4.5. When it goes farther out is when we're reaching this. So this is the end stop and this is the open stop. So this side is good and that side is no good as far as the tests. And this is where ISTA can see, because it will try to move even further to see if it stops where it wants it or where not. So in this case, I'm going to have to agree with ISTA, because this is not about position sensor, stack, or anything. ISTA is reaching farther down than what it's supposed to. And this is enough to condemn the turbo. So ISTA has created a test plan that can tell you how much is actually the wastegate being able to be pushed one direction or the other direction, and tell you the limited stops are too far. All right, guys, I hope that, I know this is going to be a very long video. I'm trying to put as much as good information that I can share with you guys on how to perform this test and what you are expecting to see with a turbo that is failing. So in this case, we know that as soon as the computer starts to see that and it does these limits positions and it sees that it's off, it just sets the turbo to a default to protect the engine. And this is exactly what we see here. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.